Welcome everyone to this event on the life and legacy of the remarkable Archibald Vivian Hill, known to all as AV. Scientist, Nobel Prize winning physiologist, Cambridge Don, politician and humanitarian. And we'll be hearing about all of those different aspects of his life and career this afternoon. This event marks two deliberately interconnected events. The centenary of the award of Hill's Nobel Prize for Physiology and the imminent launch of the new book, Bound by Muscle, which looks at the parallel lives of Hill and his Nobel Prize co-winner, the German physiologist Otto Meyerhof. I'm Alan Packwood, the director of the Archive Centre, and I'm just the host this afternoon. The real organiser and the real chair of our proceedings is Dr. Andrew Brown, the author of the new book, and I'll introduce him more fully in just a moment. But first, just a few of the normal housekeeping notices. We're not expecting any fire alarms, so if they go off, please evacuate, and we'll assemble at the Barbara Hepworth sculpture outside. We are recording this afternoon's sessions, so if you don't want to appear on film, then it's probably safer not to ask a question. And we intend to make the recording available as soon as possible through the college's YouTube channel. We're also streaming to an online audience, so hello to everyone who hasn't been able to make it here in person. When it comes to the questions, and we'll take questions after each of the presentations this afternoon, we have a roving mic for those of you here in the audience, and it would be helpful if you could wait for it, because then those online will be able to hear your questions. For those of you who are online, you need to place your questions in the Zoom Q&A function. And I'll pick them up from there. At the end of today's session, at the end of the afternoon, you're all invited to a drinks reception just around the corner in the Jock Colville Hall of the Churchill Archive Centre, where we're also going to be putting on a display of some of our A.V. Hill papers, including his citation for the Nobel Prize, which has only recently been deposited with us by the Physiological Society. And I'm afraid to those of you online, this drinks reception will be an in-person event. That brings me to the reason why the Archive Centre is hosting this event. We tend to be best known as a repository for political collections, for housing the Churchill and Thatcher collections, complete with cigars and handbags. All true, of course, but only part of the story, because from its very inception, Churchill College has also collected the papers of prominent scientists. And among the first to arrive with us, even before the construction of the current Churchill Archive Centre building, were files deposited by A.V. Hill himself. And that collection has since been generously topped up by the family, with, I believe, more material coming in as a result of this symposium. And the Hill collection now comprises some 71 archival boxes. The material is open, the catalogue is available online, and anyone can come and consult it by appointment in our reading rooms. Andrew's book, and I'm sure the talks this afternoon, will highlight for you some of the treasures within that collection. I want to thank the Hill family for their support over the years. And I'm delighted that Alison is one of our speakers today and that we have Nick and others in the audience. Andrew's assembled some expert speakers to guide us through the different aspects of A.V. Hill's remarkable life, and I'm going to let him introduce each one of them in turn. But I'm grateful to them all for giving up their time and expertise this afternoon. So now to introduce Andrew Brown. I suspect he's known to many of you already. And like A.V. Hill, he is something of a polymath, a British-born physician with a career in the United States as a radiation oncologist who's become a leading historian of science. And importantly, an historian of science who is able to span the art-sciences divide and explain the science in a way that non-scientists like myself can understand. I first got to know Andrew properly when he was working here as an Archives By Fellow on his biography of the physicist and peace campaigner Joseph Rotblat. But he's also produced biographies of James Chadwick, whose papers we also hold in the Archive Centre, and of J.D. Bernal. A.V. Hill is an equally interesting subject, a Nobel Prize-winning scientist and the Member of Parliament for Cambridge University during the Second World War. But I think Andrew's now going to take us back to where it all started. Andrew.
Well, Alan, thank you for that generous introduction. As readers of my book will discover in chapter 1, it's not quite the centenary of the Nobel Prize. It was actually awarded in 1923, having been left over as vacant from 1922. But Hill was actually the first biological scientist from Cambridge to win a Nobel Prize for physiology or medicine. And since his award, of course, there have been dozens more. This is a recording of the actual start in a little notebook kept by his mother, Ada, who recorded that he was born on September the 26th at Lindsay Villa, Clare Road, Cottam. Clare Road, Cottam, now as then, I think is a sort of quite an affluent area. They lived there because his father was boss of a family business of timber merchants in the centre of Bristol, which had been there for over a century. And his mother, Ada, was also born in Bristol, but mostly raised by her grandparents in Devon. And this is a picture of the 25-year-old Ada with her young son, Archibald Vivian. I've never discovered where those names come from, but as Alan suggested, he wasn't overly fond of them. Ada had a very, like any young mother, was very impressed by her son's intelligence at an early age. And I think she was a very loving and quite determined woman. And as evidenced by that little notebook, was an assiduous record keeper. And in fact, a lot of the papers in the archive at Churchill here, I think wouldn't have been there without Ada's collecting habits. About 18 months after AV was born, this is him, he was joined by a sister, Audrey Muriel. And shortly thereafter, the marriage dissolved because Jonathan Hill was found to be having an affair with Muriel's nursemaid. So Ada took her two children out of the house and they rented a different house in Bristol. And in fact, her parents then played quite a large role in the early years of AV's upbringing. About the time he was 8, they moved to Weston-super-Mare, where she entered him into a private school called the Breen Villa School, where he was quickly top of the class and also very competitive on the sports field, noted for his bad temper if they lost at hockey. This photo was taken when he was 13, which would have been about the time that he was taking entrance exams to go to Blundell School, which is in Tiverton in Devon. And they'd been advised to do that by the school doctor at Breen Villa, who had got to know AV and suggested to his mother that he was a very bright boy and actually helped her out with the fees for them to go to Blundell's. He was very immediately successful and popular at school. He was a day boy. There were about 300 boys in the school. His report at the end of the first term said that he was brilliant. His work was full of intelligence and energy. And this was at a time before grade inflation was commonplace. He excelled on the sports field as ever, and he took up rifle shooting. So the caption here said a Bisley boy. So Bisley being the national shooting competition, where he won the prize for under 16s within about 6 months of starting. And this had quite an impact on his subsequent career, as we shall see. This is a photo of him in his last term at Blundell's, where he conquered the sports day, winning virtually all the athletic events. And by that time, he'd also become the leading mathematician in the school, and he decided that he wanted to read maths at Cambridge. It would have been easier for him to go to Sydney, Sussex, which had some closed scholarships with Blundell's, but he decided he wanted to go to the sort of nucleus of British mathematics, which was Trinity College. So he sat on the open scholarship, got the top open scholarship, also got a scholarship from open to boys from schools in the west of England, and arrived at Trinity in 1905. Despite the scholarship money, his mother was still worried that there wouldn't be sufficient funds. And she wrote to Rouse Ball, who was a mathematician who also acted as administrator for the college. And he said, well, we can offer you the cheapest rooms, but if that's too much, he might want to take lodgings in the town. Anyway, they scraped together enough money to get rooms in Trinity, and he set off on the mathematics degree. His director of studies was a man called the Reverend E.W. Barnes, who was a leading mathematician of the day, later became quite an infamous Bishop of Birmingham. But at that time, he lectured Hill on differential equations. He was also taught by Whitehead, A.N. Whitehead, who taught him statistics. 1905 was the year that the quartet of Einstein's great early papers came out, including special relativity. And this obviously permeated the Cambridge department. And Hill said he remembered Whitehead talking about space and time very funnily, but he never understood it. He never claimed to be an intellectual. So the maths course was dominated by the Tripos exam, which was a very competitive exam taken after the first 2 years. And you tended to have a coach for that. You paid a coach to train you for the particular sorts of questions that might come up. And he hired R.A. Herman, who was the top coach of the era, and was listed third. He was known as the third wrangler in the ranking of the exams. By that time, the Tripos system had become quite unpopular, both with the maths dons and with the students, most of whom didn't want to be labeled as failures at that stage of their career if they didn't do well. And as early as 20 years earlier, George Darwin, who was the son of Charles Darwin, said that they gave the impression that any problem that couldn't be solved in 25 minutes was never going to be solved. So he was against it from that time. And then Hardy, the leading pure mathematician of the day, also was strongly against it and persuaded the university to change it. But Hill was in the penultimate year that still took it. So he went along to the Senate House to see where he came, and he went with his great friend Charles Darwin, who was George Darwin's son, and Harry St. John Philby, father of Kim, was also there. So although everyone was pleased with him finishing so high in the rankings, R.A. Herman, his coach, wrote to him and said, I really don't think you're going to make the grade as a mathematician. And so A.V. went off and talked to this man, Walter Fletcher, who was his personal tutor, a very good friend of his, a fellow athlete. And they discussed it. And Hill, I think, knew that he wasn't going to be a great mathematician. And Fletcher said, well, you should switch to natural sciences. And if you can afford to spend an extra year, why don't you do physiology? So that's what he did. And he obviously, he graduated with first-class honors, and then got a position as a researcher in the department, which was a very small department at that time, headed by this man, J.N. Langley. And Langley had succeeded Sir Michael Foster, who set up the department in a 3-room space somewhere in the university. And Langley also took over the Journal of Physiology, which went bankrupt, and he bought it out and became the sole editor. He had been a joint editor. And he set Hill his first research projects, which I'm sure Nancy will be talking about. So Hill, based on the first year of his research, was awarded a fellowship, a 5-year fellowship at Trinity, when Charles Darwin wrote to him and said, "I'm sure you'll be a bore at high table every night." So this became, coincided with the build-up towards the First World War, which I'd always thought had, been poorly anticipated, not expected really by anybody. But it was certainly expected by Hill and his friends, or some of his friends, at Trinity and at Cambridge University. So this is a picture of the officers' training corps wireless signals section. And that's AV there. And this man here is, ironically, was a man called Chubby, I've forgotten his name. Doesn't matter. So anyway, they held exercises around Cambridge and even visited the battlefield of Waterloo. All their equipment was made in the engineering laboratory of Hopkinson. And most of or a lot of Hill's contemporaries were also in officer training corps or had registered with the army. This was a picture of Hill as a fellow at Trinity, where a near neighbor was Bertrand Russell. And Bertrand Russell, of course, was a leading First World War opponent when it started, even went to prison. But as was Hardy, and even J.J. Thomson, who was a relatively apolitical figure, wrote to the press deploring the idea there might be a war with Germany, correctly predicting what a tragedy it would be. So Hill, up to this age, had led a fairly monastic male-dominated life, apart from living with his mother and his sister. So Russell invited him to a weekend party in Oxfordshire, and Russell's wife put a note in saying there'll be dancing on the Saturday, and I understand you don't dance, so you needn't come until Sunday. But then everything changed in 1913 when he met Margaret Keynes. And this is a drawing of Margaret Keynes by Gwen Darwin, later Gwen Ravera, which I think is a spectacularly good drawing. This is a photo of her at around the same age. And Margaret was a complex character in her own right. And at the time that she met Hill, really through her mother ran every charitable outfit in Cambridge, including something called the Boys' Employment Registry. And Hill somehow got an introduction to go along to that and met Margaret there, but she really didn't take much notice of him, but her mother did. And her mother kept writing notes to Margaret saying, how handsome he was, how he'd just come back looking bronzed and healthy from a sailing trip and all the rest of it. The problem was that Margaret was in a lesbian relationship with this woman on the right, whose name was Eglantine Jebb. And Eglantine Jebb, she had worked for Margaret's mother at the Boys' Employment Register. And of course, with the pressure coming from Florence Keynes to her daughter to get interested in AV, Eglantine got pushed out of the picture. And in fact, when Hill went round to propose to Margaret Hill, John Maynard Keynes, her brother, walked in on the event and pitilessly described it, saying, how nervous Hill was, and how he said Margaret is more deeply entangled than ever in a sophistic affair. And in fact, Eglantine behaved with extreme nobility, I think, and went off and did some more charity work in Eastern Europe. This blue plaque is Cambridge City's tribute to Eglantine Jebb, who was one of the great humanitarians of the 20th century. She went on to found Save the Children. And I can tell you, because I've blown up my picture of this, at the bottom it says, "Every war, just or unjust, is a war against the child." And I think it's a pity that they stuck it up on the wall instead of putting it down in the window of Cambridge Nails where someone could read it. Now, Hill, when he was a fellow, acquired this motorbike with sidecar, and he had a series of them, and they were all called Buster. I think this may be the original model, and you'll notice that the sidecar is actually made of wicker. And the Reverend Barnes, his director of studies, persuaded him to lend it to him, and he said to him afterwards, "You know, Hill, the faster you go, the more fun it is." And Hill said yes. He said a lot of students have told that story in a magistrate's court. So this was also the vehicle that took Avie and Margaret to the Isle of Skye from Cambridge on their honeymoon, and was also the means of transport he used for Otto Meyerhof on his first trip to England, when the bar connecting the two parts of it broke, and they had to find a local blacksmith to reconnect them. Most famously, on the day that the First World War started, he got a phone call from Maynard Keynes saying he needed to go into the Treasury, and they thought the trains wouldn't be running. So Avie drove him down to Whitehall for his meeting at the Treasury, and he insisted on getting out a few streets away so he wouldn't be seen arriving in this contraption. So this is a photo from 1914, by which time their first daughter, Mary Eglantine, always known as Polly, had been born. Avie was called up immediately, and I think because of his background as a Bisley shot champion, was made a musketery officer for a couple of regiments in the Midlands. And this lasted until the New Year's Day 2016. He had a letter from this man, Horace Darwin, who was another of Charles Darwin's sons, who was an engineer and had started a company called the Cambridge Scientific Instrument Company. And Horace Darwin had been recruited by the government to join something called the Munitions Invention Department, and had set up an experimental anti-aircraft section. So in those days, there was no experience of aeroplanes in warfare, and this he was tasked with coming up with some sort of anti-aircraft defense. And he immediately contacted Hill because he knew him, and he thought he would be a good candidate to run this. And so Hill went down to London on Buster, met Horace Darwin, and they agreed he would go to Uphaven, which was where the Royal Flying Corps had an experimental air base. And Hill went to Uphaven for about a week, and it's where he met Henry Tizard, who you'll hear about in David Zimmerman's talk. And Tizard talked to him about various ways they got to try to track aircraft. And in fact, what Hill came up with was this invention, which later became known as the Darwin-Hill Aerial Position Finder. So this was a flat horizontal mirror which has grids etched into it to divide it into squares. And an observer would look through this eyepiece, which was at about a foot above the glass. And there were two of these situated up to a mile apart. And so they would be connected by radio telephone. And the two observers would look for the image of a plane reflected in this mirror. And they would make a mark with glycerin ink to record the position that they saw at a given time. And through this, Hill came up with a series of equations that you could use to determine the position of the airplane in space. And obviously this all took a bit of time and was quite complicated. This is a picture of it in use, probably the first model. You see mirror position finder, Cambridge, spring of 1916. So this is AV leaning over. Watching this man here is Rafe Fowler, who was plotting in the path of an aeroplane. And Hill had come back to Cambridge because he realized that he needed more mathematical brain power in the anti-aircraft section. And he went to see G.H. Hardy, even though he was fanatically against the war, and said, I need some good mathematicians. Who have you got? And Hardy said, I'm not going to prostitute my brains by applying mathematics to warfare. And eventually Hill left with the names of two. Rafe Fowler was one. And the second one was this man, E.A. Milne, who was actually still a Trinity undergraduate, who'd come in 1914 and was not eligible to be called up because of his poor eyesight. And so they became founder members of what became known as Hill's Brigands, who were a group of scientists and engineers who looked into developing anti-aircraft techniques and also actually the first objective ideas on artillery fire, which previously had not really been quantified. One of the things that Fowler and Milne used to do was to go up in a plane flown by the Royal Flying Corps to measure pressures and temperatures at high altitudes. And Fowler hated it and Milne loved it. So because the pilots used to do acrobatics on the way down again. And by the end of the war, they'd assembled data on artillery guns under various conditions. And this was a huge chart. There's just about a quarter of it, showing the trajectory of shells which would have come up from down here and come down. But these are done under different conditions of wind and weather and shell types, I think. Because for anti-aircraft fire, it doesn't just matter where your shell lands. You want it to explode next to a moving target. So it was quite important to know the whole trajectory. They did this courtesy of the Royal Navy down near Portsmouth on HMS Excellent, which was actually not it was a stone frigate. It wasn't a seagoing ship. But Hill showed his great grasp of physics and physical science in that before anti-aircraft fire, the angles of fire tend to be quite low. But for anti-aircraft fire, they were greater than 45 degrees. And what they found was that a high proportion of the shells that were fired above 45 degrees didn't explode. They were called blind shells. And no one could work out why this was. And Hill had the idea it was to do with the rifling inside the barrel of the gun. And that it was actually the angular momentum of the shell which delayed the time of the explosion of the bottom of the shell. And they did an experiment to determine that by ordering guns with different spiraling inside the barrels, and they found the one with the least spiral gave the best results. So henceforth, all aircraft guns in England, in the UK, were made with that specification. The other thing that Fowler wanted to do was to check the actual trajectory of these shells, and he really didn't know a practical way of doing it, being an applied mathematician. And Hill's suggestion was you just have like these mill boards that they used for target practice when they were doing rifle shooting. And you'd have these 60 feet apart. And they were interested in the way that the shell rotated, what was called the yaw. So it came out of the mouth of the gun slightly off-centered, depending on the asymmetry of the barrel and the rest of it. So it would spin in a slightly oblique way. And by shooting it through this series of mill boards, they were left with a 60-foot image of what the shell was doing. And I think that's all I have to say. Thank you.
Thank you very much. We're going to take a pause for questions after each of our speakers. So a reminder that we have roving microphones for those of you in the hall. If you can just wait for the microphone to come to you if you have a question or comment. And for those of you online, if you'd like to submit any questions or comments via the Zoom Q&A function. So throwing it open for questions and comments from the floor. I'm looking for a question or comment from the room, first of all. So Jürgen in the third row.
Thank you for a wonderful talk. I bought your book a couple of days ago, and I only read the first 2 chapters, and I'm very impressed about the information you have gathered about A.V. Hill and his family. I'm an exercise physiologist, and I think his exercise work up in Manchester, lasting only 2 years, is probably the most famous work he has done, and this is work that are still cited. A.V. Hill never worked with the great scientist in Cambridge, Hopkins. Why these two could have made an extraordinary team to conquer muscle metabolism?
Yes, well, Hopkins and Fletcher wrote a very important paper on lactic acid in 1907, and they gave lectures in the First World War at the Royal Society about lactic acid. And in fact, Hill did work in the same department. Although Hopkins became a biochemist, they all worked together in the physiology department. And Hopkins at that time was discovering vitamins. And he had these cages of rats in the basement of the laboratory. And Hill was down with the rats in the basement. So they worked side by side. And the other man who worked with Hopkins was Keith Lucas, who helped Hill in his very early research. And Lucas was actually killed in a flying accident in the First World War.
Okay.
Can I ask one more question? A.V. Hill was a fellow at Trinity College until 1916, I think.
Yeah, 15,
and then he got a fellowship at King's College.
Yes.
So was there anything about his relations to the war that was the reason why he did not continue on Trinity College?
I hadn't thought about that question. I don't think that it was held against him personally. I mean, he actually had to stay on. He didn't get back to Cambridge until 1919 because he had to prepare all these reports on anti-aircraft matters. No, but his fellowship was not renewed while he was in the army. And he was rather sad about the state of Trinity after the First World War, particularly in terms of the chemistry department and other science departments. He wrote to Walter Fletcher about that. Fletcher had also left by then to become the first secretary of the Medical Research Council.
Okay, so looking for any further questions. So we do have a couple of questions, comments online. Firstly, from Kirsten Hall. Thank you for a most interesting talk, Andrew. To my shame, my only knowledge about Hill was from his correspondence with physicist William Asbury. So this meeting promises to be a real eye-opener, and I'll definitely be putting your book on my Christmas list this year.
Yeah.
And from Robert Boyd, thanks, brilliant intro. What do you mean by lesbian with regard to Margaret and Jeb, please? My mother was a great friend of Margaret in her later life, so intrigued.
Who was that?
And that was Sir Robert Boyd.
Right. I don't know who his mother was, but I mean, they had a very intense, passionate affair. And in the archive, there are lots of letters between the two of them. And as I said, their first daughter, the Hills' first daughter was Mary Eglantine, but she was always known as Polly because that was Eglantine's name for Margaret. And they wrote to each other about getting married. they were going to set up house together in London. So it was a very intense relationship, but of course wasn't against the law, unlike male homosexuality at the time.
Okay, well, I think at this point,
Nick has a question.
we'll go to Nick Humphrey and then we must move on. So, Nick?
So not such an interesting question as Robert Boyd's. His mother was Amelie Boyd, a great friend of Avie and Marge. The question I've got is about the anti-aircraft work. You say a great deal about these preparations for shooting down aeroplanes, very little about what success they actually had on the field. And whether, and I'm not really aware of to what extent Britain was under threat from German bombers or German planes during the First World War.
Well, there were some bombing raids, but you know, the Navy prepared for it by having some guns on the roof of the Admiralty in London, which had no particular, I think they had no particular skill in operating. Now, I think the most important consequence of the work they did was actually this stuff on artillery fire, which was still the papers that, there were two huge papers that Fowler and Hill and others wrote up, I think at the Royal Society, and they were apparently used a lot during the Second World War, or in preparation for the Second World War, not so much really for anti-aircraft fire. But this whole business did mean that Hill's name was known to the military, and it was why he was drafted in to advise on the Tizard Committee before the Second World War.
Okay. Well, Andrew, I think you've done an excellent job in sort of setting the scene for us and just giving us an impression just of the amazing sort of knowledge and breadth that Avie had as a young man. I think now we're going to move on and to look at some of his science, and I wonder if you can introduce our next speaker.
Of course. I'd be pleased to introduce Nancy Curtin. We have a number of Hill's biological grandchildren here today, and I think Nancy's really a scientific granddaughter of Avie Hill. She did her PhD on muscle physiology in Philadelphia, actually with an English professor, R.E. Davis, or he may have been Welsh, but who I was reading got into a controversy over Avie Hill with the editor of Nature, because Hill issued this challenge to biochemists to show that the molecule ATP was important in living muscle for contraction. And Davis, some years later, wrote an answer to that challenge and included Avie's name in the title of the book, in the title of the paper, and the editor just took it out and he was furious. And then Nancy, after finishing her PhD, came to University College London, where Hill was professor for many years, and worked with Roger Wallage, who was, I think, Hill's last PhD student, or certainly one of his last. So, Nancy Curtin.
Okay, I'm going to talk about Avie Hill's Nobel Prize Science and its legacy. So my talk is really in sort of two parts. Now, the Nobel Prize for Physiology and Medicine for 1922, as we've already heard from Andrew, was awarded jointly to Avie and to Meyerhof in 1923. Avie's award was for his discoveries relating to the production of heat in muscle, and Otto Meyerhof's for his discovery of the fixed relationship between the consumption of oxygen and the metabolism of lactic acid in muscle. Their work was complementary, and I'm sure many people who were in the audience at the Nobel Prize lectures agreed with Meyerhof's statement that it is especially gratifying that this recognition is shared with Professor Avie Hill, with whom, in spite of present political unrest, I have worked in cooperation. So what led AV to be awarded to the Nobel Prize? It was partly due to the state of knowledge, or actually the gaps in the knowledge at the time. And the paper by Fletcher and Hopkins, which Andrew mentioned, about lactic acid in amphibian muscle, sets the scene quite well. In the introduction, they wrote that it is notorious that there is hardly any important fact concerning lactic acid formation in muscle, which, advanced by one observer, has not been contradicted by some other. So things were in quite a stagnant state at that point. However, Fletcher and Hopkins resolved the controversies about the formation of lactic acid by developing a better method of extracting the lactic acid from the muscles so it could be measured. And their method, their new method, the point about it was that it was quite a sort of gentle method. And the important thing was that it didn't cause the muscle to actually produce lactic acid, which made the control muscles more like the test muscles. Every muscle was stimulated to produce lactic acid. They went on to investigate the disappearance of lactic acid in oxygen, but they actually made no conclusions from this part of their study. And this was because it seemed quite likely that the diffusion of oxygen into the large muscle groups that they had to use to get enough lactic acid to be able to measure it, that the diffusion of oxygen in was too slow to actually resupply the oxygen that was being used up. So they knew that they couldn't get a really accurate picture of what was going on. So Fletcher and Hopkins left open questions about how lactic acid actually disappeared. How could it be investigated? And this was one of the important points that was an open question and quite inviting investigation. So what got Hill actually involved in the heat measurements on muscle? AV finished his degree studies in 1909 and joined the physiological laboratory with Langley as its head. And Langley suggested that AV should settle down to investigate the efficiency of cutout frog muscle as a thermodynamic machine. Now, just an aside here, the reference to thermodynamic machine here is a reference to the law of conservation of energy, which means that the energy, the heat and the work that's released by the muscle has to be equal to the energy that's produced by the chemical reactions which are happening inside the muscle. I should say that at the time these experiments were done, AV's first experiments, all of the experiments were designed so that the muscles actually did not produce any work. All of the energy was coming out as heat. So heat was really important. So the law required a balance between the energy output from the muscle as heat and the energy input that came from the chemical reactions, and measurements of both heat and chemical reactions were needed to test this balance. If there was an imbalance found, it meant that something was missing in the description and it needed to be discovered. From the point of view of heat measurements, the energy balance approach, this balance approach comparing the two sides of this equation, one of the strengths was that all of the reactions that happened inside the muscle, even ones that were unknown, contributed to the heat. So he had some evidence about them. A weakness of the approach was that heat itself doesn't give any direct evidence about what these chemical reactions are. the next question to consider was how are these heat measurements going to be made? And AV recounts that Langley, as if by magic, produced a beautiful little instrument, a thermocouple and a galvanometer in one. And this had been made by Blix, who was a Swedish scientist. And he'd given it to Langley with the assurance that it could detect the heat produced by a muscle during contraction. So how did it actually work? Oh, sorry, how did it actually work? So that's what this, that's what this part of the slide is hopefully going to explain a bit. So a thermocouple consists of two different metals joined to form a junction here. And the principle upon which it works is the thermoelectric effect, which is that if the two ends of metals are at different temperatures, they produce a voltage signal which is proportional to the temperature difference. Now, in the experiments on muscle, the junction is in contact with the muscle, and the muscle controls temperature 1. The other end of the metals are at a reference temperature, which is kept at a constant value. Now, the key thing here was that the couple actually touches the muscle. It doesn't actually have to penetrate the muscle cells. And in fact, usually in these experiments, these early experiments, they used a thin muscle, and the thermocouple was between the two muscles. And so that was a distinct advantage. Heat could be measured without damaging the muscle at all, unlike the chemical experiments. The other advantage was that using very thin muscles, oxygen could diffuse quickly into the muscles and avoid this oxygen supply problem, which Fletcher and Hopkins had encountered. So here was a method that was a possible improvement on Fletcher and Hopkins' methods, and AV went for it. So what were the experiments that actually led up to the Nobel Prize? Well, AV and his colleagues in the lab had published 24 papers in the period between the time that he joined the lab and the award of the Nobel Prize. Many of these papers were quite technical, to do with the improvements of the thermopile and other aspects of the methods. And in other cases, the conclusions of the papers were overturned by later developments or advanced, and interpretations changed as a result of later developments. But in AV's book, 1965 book, Trails and Trials in Physiology, he identified 3 papers which had stood the test of time and still regarded as standing as exactly as performed and described. The first was Hill, 1913, where he described recovery heat. And the second was one of his colleagues in the lab, Weizsäcker, whose paper in 1914 showed that initial heat did not require oxygen. And then lastly, a paper by Hill and Hartree in 1920, which described 4 phases of heat production, 3 in initial heat and 1 in recovery heat. And I'll say a bit more about these, but first I want to just have a little interlude again about the First World War. So this is a picture of some of, or maybe all of, AV's brigands who were involved in the anti-aircraft gunnery. Here's AV in the middle. And one of the scientifically most valuable outcomes of this for AV was William Hartree, who was one of the brigands. He enjoyed working with AV so much during the war that afterwards he returned to Cambridge. Here he is in Cambridge. And continued to work with AV until 1933. His particular expertise was in the number crunching of the heat results. And this was in the days when all of the calculations were done with pencil and paper. So it's quite an asset to have such a colleague. Looking at this picture, I'm intrigued by this. I don't exactly know what it is. I wonder if it might be a sort of state-of-the-art slide rule. But if anybody knows, I'd be very grateful to know about it. Okay, so getting back to the science, these two graphs explain some of the results concerning initial heat and recovery heat. In both cases, we have heat plotted on this axis and time on the x-axis. The important things about the initial heat is, first of all, we see a very small time scale here, up to 3.5 seconds. The bar marks the period during which the muscle was stimulated, and we see that during that time, heat is produced at a high rate. It continues to be produced at a high rate for a short time after the end of the stimulation. And then the heat production, the initial heat production, stops. The other important thing about it is that we see that the amount of heat that's produced in oxygen and in nitrogen is virtually identical. So it's clear that the processes that produce initial heat do not require oxygen. This graph over here is about the recovery heat, and it starts to be produced after the initial heat is over with, after the contraction is over with. And it continues for a very long time. So here the scale goes up to 500 seconds, or about 9 minutes. The recovery heat continues to be produced. Interestingly, the actual amount of recovery heat is not that different than the initial heat. The actual quantity that's produced, it's just the time scale over which it is produced, which is very different. Now, unlike the initial heat, recovery heat does require oxygen, and only a very small amount is produced in the presence of nitrogen. Now, this next slide is a sort of block diagram, which is interesting. There are hardly any diagrams in papers published at this time. This is in Weizsäcker's paper near the end, his conclusions. He identifies 3 energy sources and 2 different processes or transformations between them, the recovery engine and the contraction engine. The recovery engine is the one that produces recovery heat, and it requires oxygen. So if in the absence of oxygen, it doesn't occur. The contraction machine down here is the one that uses the potential energy from some unidentified chemical in the muscle to get transformed into what he calls mechanical energy, which is heat and force. And what Weizsäcker showed in his experiments was that the heat and the force, the initial heat and the force is identical, whether absolutely identical, both in the presence and the absence of oxygen. So that was those 2 papers. The third one was more about the initial heat, Hill and Hartree's paper in 1920. And it described 3 phases in the initial heat. This, well, I should say here, we've got heat and force on this axis and time here for a brief contraction that ends at this time. This is the record of the force being produced, maintained, and then relaxing after the end of the stimulation. Each of these blocks shows the rate of heat production during that particular time interval. And the 3 phases are this very rapid phase of heat production, very beginning of the contraction as force is building up. Then there's maintenance heat, fairly steady rate until the end of stimulation. And then during relaxation, as force declines, there's another little burst of heat. So those are the three phases of heat production, the initial heat production. Now, the important thing about these, or bottom line of these three papers, one of them anyway, is that if you're going to try to understand, say, these phases of heat production, initial heat production during the contraction, or if you're looking for what this unknown chemical X is, that any reaction that involves oxygen can be excluded from the search. It isn't involved because all these experiments showed that initial processes don't involve oxygen, whereas recovery does. Okay. Now, in 1920, AV moved to become the head of the department at Manchester University. And there are sort of three notable things that happened during that time. Fenn, who was a young American physiologist, came and worked with AV and did some very influential, or turned out to be very influential experiments, which showed that whenever a muscle shortens and upon stimulation and does work, an extra amount of energy is mobilized. And this paper was published in 1923. It was important because it was the first step towards overturning the prevailing view at the time, which was the contracting muscle is an elastic body. Being elastic requires that the amount of energy it releases doesn't depend on whether it's work energy or heat energy, and work shouldn't increase the amount of total energy that's produced. And AV followed up on this some years later. During this time, AV also started his research on human exercise with Hartley-Lumpton, and its aim was to see whether what AV had found out with isolated frog muscle also applied to humans. And the last point I'll note here about the Manchester time was AV hired A.C. Downing, who was an excellent instrument maker, made thermopiles and galvanometers, and he came with AV to UCL later on. The move to UCL was in 1923, and he was head of the department at UCL until 1926, when he took up a Royal Society Fullerton research professorship. UCL remained AV's research center, research base for the rest of his career. Shortly after he arrived at UCL, the Nobel Prize was announced. So what was the legacy now? We're moving on to what happened after the Nobel Prize. This graphic shows the impressive number of AV's collaborators. Over 100 scientists are listed here who have joint publications with AV in 5 different fields. Each of the circles down here indicates the first paper in collaboration with AV written by one of these scientists. And down here we see for muscle, after the Nobel Prize, we have a very high concentration of dots. I think there are a whole lot of them that are superimposed there as well. Now, I think the legacy of AV's Nobel research is probably best summarized by quoting from an article that my friend and colleague Chris Barkley and I wrote recently. And it is that the main ideas of the work for which the Nobel Prize was awarded were superseded within a decade. And the legacy of Hill and Meyerhof's Nobel work was not a set of persistent, influential ideas, but rather a prolonged period of extraordinary activity that advanced the understanding of how muscles work far beyond the concept that led to the Nobel Prize. And in our article, we tried to summarize some of the legacy in this, which was what's called the abstract figure in our Journal of Physiology article. All the things that are inside the blue box here are directly in the realm of muscle physiology. And then there were various sort of spin-offs, which I'll describe briefly. So we can, we've already mentioned a bit about the application of the principles of thermodynamics to muscle contraction. AV also described the relationship between muscle force and muscle velocity, this curved relationship which applies in all vertebrate muscles that have been studied, different curvatures for different types of muscle. He also, in the same paper actually as he described these, he set out this two-component model of muscle, which consists of a contractile component, which has properties like this, and at the ends of the muscle, a series elastic component, which has just elastic properties. And this in the isolated muscle experiments is a bit of tendon, always minimized, but there's always a bit of it there, and it does have an influence. This two-component model is widely used in the field of biomechanics, which is trying to understand how muscle, tendons, bones, joints, ligaments all work together to produce locomotion. And this model is widely used in that field. If we move over here, the steady state of muscle contractions and oxygen debt established in isolated frog muscle experiments carries over pretty much directly into exercise physiology, and AV will have been directly involved in this transition into, or introduction into, exercise physiology. And here we have this graph of the relationship between the concentration of an ion or a ligand and the effect that it produces. And this S-shaped curve was something that AV worked on even before he did muscle, right at the beginning of his work in the physiology laboratory, and that he wrote the equation that described this S-shaped relationship. Has a parameter n, which is called the Hill coefficient, and describes the steepness of the steepest part of the curve. This S-shaped relationship between the ligand and its effect is one of the sort of bedrocks of quantitative pharmacology, and also is widely used in biochemistry. And then lastly, just the general principle of applying mathematics and physics to muscle physiology was one thing, but applying it to other tissues or other types of cells really was the basis of the foundation of the related science of biophysics. And AV is regarded as one of the founders of biophysics for this reason. Now, I think that the prolonged period of extraordinary activity that advanced understanding, I think that in addition to all the scientific things, it also depended on some aspects of AV's personality. And here's a photo of AV and Meyerhof outside the Hill's home in Highgate. And I think it's clear AV enjoyed his colleagues. It was good fun. He also was an enthusiastic supporter of scientists in general. And here is a photograph with AV in the middle and looks like AV's in his element, which I think indeed he was. This was en route in 1929 to the first time that there was an International Physiology Congress in the United States. And there, aboard the ship that AV arranged to provide transport for physiologists from Europe to Boston, where the conference was. And he did this, AV made these arrangements on behalf of the Physiological Society, for which he did a great deal of work. And then the very last thing, I'd like to end with, again, a quote from AV from Trails and Trials in Physiology, which again gives some flavor of what he was really like to work with. He said, "Often I have told my young friends that when they have found something they cannot understand at all, instead of being cast down, they should jump in the air for joy. For it is often how discoveries are made. Research must indeed be planned, but the most interesting things can emerge when the plan does not work, providing a test not only of tenacity, but of understanding." Okay? That's it.
Nancy, thank you very much. I think we come out of that with a much better, I certainly come out of that with a much, much better understanding of the science that underpinned AV's Nobel Prize and his career. We're looking now, we don't have very much time. We ought to move to tea quite quickly, but I'd just take one or two questions quickly from the audience, if they're there. You have any questions? Frank King.
Frank King, fellow of a college. You mentioned in passing a gadget, a cylindrical gadget, a bit like this,
Yes.
standing on a table. That was a Fuller calculator. Almost all calculators like that were manufactured by Fuller. There are still plenty around, many in the Whipple Museum of History of Science in Cambridge. And indeed, I have one at home, all ready for when we have power cuts during the winter.
Oh, wonderful, wonderful. Thank you very much.
Okay, and we have a sort of further comment on that from Austin Elliott online, who says, "Thanks, Nancy, beautifully lucid, could see all the years of researching, teaching muscle there. And yes, the thing you referred to in the Hartree pick is a cylindrical slide rule."
Okay, thank you. Great.
Okay, well, on that note, I think we're going to break for tea now, which is in the Wolfson foyer just outside. For those of you online, we will be resuming at 3:30, and we'll see you then. But in the meantime, thanks to both our speakers from the first session. Thank you, Andrew and Nancy.
Our next speaker is David Zimmerman, who is somewhere in Canada, I think. He's a professor of military history at the Victoria University in Canada. He's written two absolutely essential books for people interested in the build-up to the Second World War. One about the development of radar and the defeat of the Luftwaffe, and the second one on the Tizard mission, taking scientific secrets from England to the United States in 1940, and they will be the subject of his talks. He has a new book coming out, which is called "Ensnared Between Hitler and Stalin," which concerns the fate of refugee scientists in the USSR. Anyway, we have his contribution on video.
Good afternoon, everyone. I'm David Zimmerman. I'm sorry I can't be with you today at Churchill College. Unfortunately, I have to teach first thing tomorrow morning, and I'm currently on a plane traveling between Ottawa and Vancouver, British Columbia, so I can get back to teaching in Victoria for Thursday morning. However, I couldn't pass up the opportunity to talk about two men that have played an important part in my scholarship, but more importantly, have played a central role in the mobilization of British scientists for war. That is, of course, A.B. Hill and his good friend, Henry Tizard. Hill and Tizard were contemporaries with each other. They both had been scientists in the First World War, as I know you've already heard, that Hill's military work in the First World War. But their work in mobilizing British science for war really begins in 1934. Now, Hill is invited by Henry Wimpress, who is the director of scientific research at the Air Ministry, to a meeting on the 15th of October in 1934. And Wimpress asked Hill a startling question: can death rays kill? The Air Ministry had been consumed with the fears that Stanley Baldwin had been correct when he said that the bomber would always get through. And the only idea that the Air Ministry had that seems to apply science to the problems of air defense were death rays. Hill was asked because, as a physiologist, like other physiologists, there had been considerable experimentation on the impact on living organisms of things like infrared and high-frequency sound waves. In fact, many physiologists ended up killing a great deal of animals in the 1920s. And the thought was perhaps a death ray to melt the brains of a pilot, or maybe stop the engines of the aircraft, could be used to stop the bombers from bombing London. And Wimpress posed this to Hill, and Hill thought about it for a few seconds, and he said, I really have no idea. But I think that if this is to be effective at long range, the best thing that could be used would be shortwave radio. And I suggest you talk to Robert Watson-Watt, the British government's leading expert on shortwave radio, and ask him about what he thinks about death rays. This, of course, led to the discovery of radar in 1935, at least the discovery of radar in Great Britain. Watson-Watt's famous Daventry experiments in February 1935, which showed that rather than death rays, as what Watson-Watt proposed after he had mathematically concluded that it would be impossible to build a death ray, for instance, putting so much power through a single circuit to melt the brains of a pilot would probably result in needing the entire power for the city of London, and would melt any circuit instantaneously that such a powerful beam was sent through. But he did suggest that he had been noticing, as had other researchers, that when he measured the height of the ionosphere using shortwave radio pulses, when aircraft passed by, they tended to reflect the radio signals back to his receiver. And he suggested, could we use this as a long-range method of detecting aircraft? And in fact, by mid-1935, radar, as this technology became known, was detecting aircraft at ranges of up to 60 miles. Even before Watson-Watt began his experiments, a committee was formed by the Air Ministry to oversee the development of new scientific methods for air defense. And this is what brings in Henry Tizard, because this new committee would be named after Tizard, who was its chair. Tizard was, like Hill, an experienced defense scientist from the First World War. He had remained in government scientific service after the war. He had left government in 1929 after having become the principal secretary of the Department of Science and Industrial Research. And while he was at Imperial College's rector, he also was the chairman of the Aeronautical Research Committee, so he's still heavily involved in government research work. Hill was considered an obvious choice given his experience as a scientist and as a defense researcher during the First World War. And the third scientist appointed was Patrick Blackett, the handsome man seen in the middle here. Blackett had been a naval officer during the First World War, but after the war, he discovered the joys of university life. He had become a famous young physicist, and it was felt that he would bring a necessary level of expertise and professional military experience to such an investigation. However, hoisted on the committee was the man you see in the foreground in the picture in the upper right, the man in the bowler hat, Frederick Lindemann. Lindemann was appointed in large measure for political reasons. He was the close personal friend and scientific advisor to the man standing next to him, of course, Winston Churchill. Churchill had become a thorn in the side of government, and it was hoped that by putting Lindemann on the committee, Churchill would stop asking embarrassing questions about air defense research that he was raising in the House of Commons. Lindemann was professor of physics at Oxford. He had been a good friend of Tizard. They had met in Germany prior to the First World War, but in the 1920s, the two men had had a falling out. The final member of the committee was A.P. Rowe, a government scientist who was appointed as its secretary. The committee, however, did not initially work very well. Lindemann proved, in fact, to be a very, very difficult figure indeed. Lindemann demanded that the committee follow his advice and would not accept differences of opinion. And Lindemann was particularly anxious to push through the research into other technologies beyond radar. And while he acknowledged that radar was important, unlike Tizard, Hill, and Blackett, who saw radar as the key to the air defense problem, Lindemann thought that other technologies, more radical technologies, need to be developed. And one of Lindemann's favorite technologies was the aerial minefield or parachute bomb. Lindemann advocated for the widespread development of this, intensive research. He ignored the fact there was already research going on at Farnborough into this technology. And what this amounted to was a parachute attached to wires, at the bottom of which was a small bomb. And the idea was to somehow fly ahead of a bomber force, drop these parachute bombs in front of the target. The planes would become entangled in the wires, would wrap the bomb up around their wings, the bomb would explode, and the plane would be shot down. Now, unfortunately, what Lindemann refused to acknowledge is that the research at Farnborough had proven all sorts of issues with this technology, let alone the problem of how you would magically get an aerial minefield drop in front of a bomber formation that was approaching a British cities. Still, Lindemann demanded that his opinions be listened to. He refused to accept any objections to his opinions. The committee broke down at the end of May 1936, and the battle continued until the 2nd of September 1936. Finally, in late July, Hill and Blackett, to support Tizard, resigned their positions, saying that they could no longer work on the committee with Lindemann present, and they cautioned that they feared for Tizard's health in this ongoing battle. The Air Minister felt he had no choice. He dissolved the committee, and then on the 2nd of September 1936, he reappointed a new committee with Tizard as chair, Hill and Blackett, and replacing Lindemann, Appleton, Professor Appleton, another shortwave radio expert. After this, the committee began to work extremely well, furthering British aviation research into air defense. And Tizard himself became personally involved in the famous interception experiments that were held in 1936-37 at Beacon Hill. And this was an ingenious series of experiments designed to take the information they thought they would get from radar, because this experiment was done before radar came into existence, designed to show how we could use this information from radar in order to steer fighter aircraft to their targets as they approach the coast. And these interceptions would have to be undertaken at speeds with the two air force formations approaching each other at 500 miles an hour. And Tizard quickly realized that what was needed was clarity and simplicity of information. You had to display the information clearly on simple maps, and controllers would control fighters using radio from the ground to their targets. Tizard's great accomplishment was inventing what the Royal Air Force would later affectionately name the Tizzy angle. It was an example of simplicity, which abandoned mechanical means of calculating the course to steer fighters to an intercept. Instead, Tizard suggested using an imaginary isosceles triangle on the map between the fighters and the bombers to quickly get a reasonable, accurate intercept course. This developed as the most sophisticated information processing system in the world, And when radar stations were built protecting Britain's coast, the information from the results of the interception experiments led to the creation of the air defense system, which would save Britain during the Battle of Britain in the summer of 1940. But this was not all that Hill and Tizard would do. Not only did they oversee air defense research in the 1930s, they also were involved directly in getting civilian scientists ready for a conflict. In the First World War, both Tizard and Hill felt science had been poorly used. But prior to the war, Tizard won permission. Prior to the Second World War, Tizard won permission from the government to start briefing civilian scientists on the latest research, including radar. And the first man he selected was a physicist, John Cockcroft. Cockcroft was given intensive indoctrination into radar technology, and he then was told to go out and find other scientists who could be sent to Bodsey Radar Research Establishment for instruction. As well, Hill and Tizard joined with Sir William Henry Bragg, the president of the Royal Society, seen here on the right, to create a mobilization list for all British scientists. In the First World War, many scientists have been sent to the trenches and die. There was a determination that scientific talent would be ready for war, to do defense research, to actually utilize their particular talents, which were so much more important than being an individual soldier in the front lines. Hill and Tizard also became very concerned about the question of Anglo-American military technical cooperation. After the First World War, both the American and British military ceased in any meaningful way cooperating with each other. In fact, in the late 1930s, there have been some efforts to exchange military technical secrets between the Americans and the British, but all the efforts by the service defense attaches failed because both sides displayed remarkable technical chauvinism, believing that the other side had nothing to offer. In fact, the British government representatives in Washington, the British service representatives, concluded that the only American technology of any use was the Norden bomb sight. When the British asked the Americans for the Norden bomb sight, the Americans said, well, first of all, that's the only technology we won't give you. And secondly, we don't believe you have any technology, even any way equivalent to the Norden bomb sight, to change our minds. This problem with quid pro quo actually generated more animosity than any good. And this is what the situation was when the war began in September 1939. Tizard, in 1939, became the scientific advisor to the Chief of Air Staff, a very important position which allowed Tizard to lobby the Chief of Air Staff to send an open technical mission to the United States to give to the Americans the British military technical secrets with the hopes to foster close relationships and perhaps to be made aware in exchange of American technology. The Air Ministry was very reluctant. They weren't sure that the Americans had anything. Plus, there was increasing view that the United States was filled with Nazi sympathizers. As a result of this, it took months of lobbying on Tizard and as well joined by his friend A.V. Hill to convince the Air Ministry to agree not to a mission, but for a scientific intelligence mission to be sent to the United States to see what the attitudes were of the Americans and to see if they had anything worthy of offering. Tizard wished to go himself. The Chief of Air Staff said, no, you're too important. So the best person available was A.V. Hill. Hill was selected to go. He had extensive American contacts due to his many trips there in the 1920s and 1930s. Of course, he was a famous scientist, having won the Nobel Prize. And just as the mission was about to be sent, a problem arose. Hill was elected to be the Member of Parliament from Cambridge University. The Foreign Office objected to this. And the result of this was that there was a delay because the Foreign Office didn't want Hill going because he was a politician, and politicians couldn't be diplomats. But Hill finally was sent to the United States. He arrived on the 21st of March, 1940, and there he found a supporter in Philip Kerr, Lord Lothian, who was the British ambassador in Washington. And Lothian had a history of fostering close Anglo-American cooperation. Hill made extensive tours of particularly the eastern United States, universities, scientific research centers, even military scientific establishments. But what he quickly ascertained were two very important things. First of all, almost all of the American scientific elite were very pro-British. And secondly, Hill realized the Americans had a lot to offer. One of Hill's most startling discoveries was that the Americans almost certainly had their own radar technology. This came about when an American university president said to Hill in a luncheon meeting, of course, we have a means of detecting aircraft at long range, a radio means. Well, perhaps I shouldn't have told you that, but so be it. And Hill, from his observations, just from antenna arrays at American military research establishments, concluded that the Americans had radar. But he also saw other technologies that the British could certainly use in the war. And as Hill also surmised, to give the Americans Britain's latest military secrets, which would allow American industry, if and when it could become freely available to the British military, to gear up and produce the latest and best military equipment for both American and British use. However, of course, while Hill is there, he's sending reports back, suggesting a full open exchange take place, but nothing's happening. No response. And what's happening in Britain is, of course, the fall of France. The prime minister becomes Winston Churchill. Churchill brings into government his scientific advisor, Lindemann, and Lindemann is absolutely opposed to a technical mission in large measure because it is Tizard's idea and Hill's supporting it, and he hates them both. And Churchill himself is angry at the Americans, particularly in June 1940, after the fall of France, when the Americans don't offer any practical aid to save Britain from the Germans. As a result of this, Hill rushes back to Britain in June 1940 to try to personally lobby the British government of the vital need to send a technical mission to the United States. Ultimately, in July 1940, Churchill relents after the Americans had provided some initial aid to Britain, and Lindemann had defeated Tizard in a battle in June 1940 about who was going to control the government scientific agenda. Tizard was forced to resign as the chief of Air Staff's advisor. And Lindemann now felt comfortable to support an idea since it was no longer Tizard, since Tizard was no longer part of government. The result of this was that the British government agreed in August 1940 to send a technical mission of leading scientists and technologies. They would have everything, including the most super secret devices. And this is the most super secret device Tizard is showing, not in a picture from 1940, but a later picture to two American scientists. And the picture on the right is the only known picture of the Tizard mission. The only person missing from this is John Cockcroft, the second in charge of the mission. He was taking the picture, unfortunately, in this. So Tizard arrived in August 1940 with the mission members following shortly thereafter. And Tizard and the mission members gave to the Americans all of Britain's military technologies, plus a great deal of information about how these new technologies were performing in battle. The Americans were utterly fascinated by what the British were telling them, and particularly blown away at a famous meeting on September 19th, 1940, when the British revealed their ultimate secret, the cavity magnetron valve. The cavity magnetron made shortwave or ultra shortwave or microwave radar possible. The British brought with them one of the first 12 pre-production models. This incredible new technology surprised the Americans, who had doubted microwave radar was ever going to be feasible. The result was, for the civilian scientists in the United States, who had been assigned by the US military the job of developing microwave radar, that they now had a major research project under civilian control. The Americans, in response, gave to the British all of their military technologies. Quite an amazing cooperative venture, which began effective Anglo-American technical and scientific cooperation that continues to this very day. But the Tizard returned at the end of September 1940 to try to encourage the British government to put this cooperation onto a permanent footing. Meanwhile, other scientists like Cockcroft remained behind and were instrumental in helping mobilize American science for war. They were involved in all the discussions and gave advice to the establishment of the famous radiation laboratory at MIT, which would be, by 1942, the world's largest radar research facility. Microwave radar in the United States was being mass-produced within weeks after the American entry of the war. And microwave radar, for instance, allowed for small radar sets that could destroy submarines, as in this picture. This extraordinary accomplishment of mobilizing British science and American science for war were the great achievements of Hill and Tizard in the Second World War. After the mission, Hill's work was primarily political and assisting refugee academics. Tizard, unfortunately, was not allowed back into the upper reaches of scientific advice to the government by Lindemann, and he held a series of lesser important assignments working in British scientific research during the Second World War. Only after Winston Churchill was defeated did Tizard come back as a leading government scientist. But still, despite the fact that they didn't do much after 1940 for the scientific war effort, their work had been instrumental in the successful scientific mobilization in the Second World War, and therefore played a very important role in the British victory. Thank you very much, ladies and gentlemen. As I say, I'm sorry I can't be there, but I hope and I'm sure it's going to be a fascinating symposium. Bye-bye.
I think that was a superb talk by David Zimmerman on a subject that he knows so well, but which is very complex, and it was extraordinary the way he was able to summarize it. Unfortunately, we don't know which seat he's sitting in on the plane, so we can't send him any questions. But thank you, David. The next speaker is Paul Weindling, who I met for the first time at lunchtime. He was very helpful to me when I was writing the book in providing material that he'd previously written. He's a professor of history at Oxford Brookes University and also a member of the Leopoldina, the National Science Academy of Germany. I think he's a leading authority on German science, and especially the atrocious horrors carried out by Nazi scientists and medics during the Second World War, and he's written extensively about academic refugees coming to this country. I know that Otto Meyerhof, towards the end of the war, took a very strong line about the culpability of German academics who'd stayed and helped the Nazi regime. He wanted the German universities to be closed for at least 2 or 3 years while they cleansed their academic staff, and made the point that there were German engineers and academics who designed and built the gas chambers. He was quite unforgiving on those subjects. So it's a great honor to have Paul here this afternoon.
Well, thank you very much for the kind introduction. Thank you also, Andrew, and the Churchill Archive Centre for this invitation. For me, to be able to speak about A.V. Hill is very special, and I should explain why. Because my mother came on a kinder transport to 16 Bishopswood Road, and her guarantors were Margaret Hill and A.V. Hill. And she came through, she always said she came through Save the Children, which I think was right. And the Hills chose a picture of her photo. And that was just on that basis, the generosity of the invitation, and also AV's conduct to her was wonderful. It was deeply compassionate. He took her to meet his parents-in-law, the Keyneses. He took her to, he invited her to a Royal Society Conversazione, which I think was very special, and also to Devon and so on. So for her, it was a very formative period. But I think it shows AV's, how can I say, dedication in rescuing as many of the persecuted scientists as he could. And he was always very, very ingenious in doing so. Just one example is there was a noted German pharmacologist, Herxheimer, and AV created a position for him as school doctor at Highgate School, where he was the school governor. So all the time he was trying to create positions where there were ostensibly too few or none. So it shows a wonderful dedication on his part, which I would like to illustrate through a particular life history, which is of Hermann Blaschko. Hermann Blaschko was the son of Alfred Blaschko, a noted dermatologist and founder of the German Society for the Prevention of Sexually Transmitted Diseases in 1900. And Hermann was to be distinguished for research on adrenaline and dopamine and on the metabolization of dopamine. I used to go to Hugh, as we called him, to ask about his father's activities. But one day Hugh gave me a folder of correspondence with AV and about problems of refugee scientists and physicians. And there was clearly a very, very close collaboration between the two. I think firstly, to establish the importance of Blaschko, he was very much of a Meyerhof protege. Blaschko was assistant to Meyerhof at the Kaiser Wilhelm Institute for Biology. Then he comes between 1929 and 30. Blaschko is with A.V. Hill at University College. And then in his toing and froing from 30 to 32, Blaschko's assistant. By then, Meyerhof has the Kaiser Wilhelm Institute for Medical Research in Heidelberg. And then in 1933, A.V. writes to Blaschko, it's already, how are things for you? Can I do anything to help you? So very proactive. And Blaschko says, yes, it would be nice to revisit you at University College London. And Hermann arrives with a Warburg manometer and chemicals, all set to do further research work. In 1934, he's at the Department of Physiology in Cambridge. He's also a grantee of what was initially the Academic Assistance Council, which AV was one of the founders in 1933, and it was a terrifically far-sighted move, the collaboration with people, with other significant movers and shakers like Beveridge to set up the Academic Assistance Council. But from then on, Hermann has a precarious position in Cambridge as he's occasional demonstrator and an assistant supervisor at St John's College. So he's, although he's a very capable scientist and does scientific research in Cambridge, he's still marginal. And just to mention this Society for what became the Society for the Protection of Science and Learning, the move between the Academic Assistance Council was to renaming it the Society for the Protection of Science and Learning, is that it was recognized that there would be an indefinite need for such a society. To provide grants and to open positions and to liaise with, for example, the American Embassy to get visas. You could bring people. It was much easier to come to the UK in 1933 than to get a visa from the American Embassy in Berlin. But the good contacts of the AAC with the US Embassy meant that Britain was a sort of staging post. So there was a terrific, I can say, it was a real network of support in multiple ways. And one should also pay tribute to Esther Simpson, who was the long-standing secretary of the society, who adopted whole families of the children and the wives and so on of academic refugees. In 1940, the Society for the Protection of Science and Learning moves to Cambridge, and that's really an opportunity for Herman to become very, very closely involved in doing all sorts of translation work and preparing dossiers and being a sort of middleman and keeping AV informed on all sorts of issues and responding. At the same time, it's how can one say it, a very strange situation. Hugh, I mentioned, has a very precarious position, and there is a rather aggressive anti-refugee propaganda. And he was particularly disturbed by a society of British chemists. This was even had some small publicity in the journal Nature, and it resented subsidies to foreign academics. I think there's a link to the British Union of Fascists, and Herman felt this intensely. He'd previously encountered very direct prejudice when he was nominated by a job for a provincial university, but was then rejected by the university senate. And it was only, in fact, in 1944 that Hugh is offered by Joshua Byrne when he hears how precarious Herman's position is, to have a research position in pharmacology in Oxford, which became permanent, in fact. So one can, so that, it was really, on the one hand, he was central regarding the developing and creating positions for other academic refugees, but his own position was really very modest. This is just one example of how things were for Herman in Cambridge. This is regarding Keilin and Dixon in the Molteno Institute. It's and he says that they have reached a sort of research crisis in finding that they omit the substrate hypoxanthine for a crucial experiment. And there is apparently none of this substance in Cambridge whatsoever. So Hugh writes, maybe I could help. What's the substrate? They said hypoxanthine. Oh, I said, let me have a look. And I went to my room in physiology and came back a few minutes later with a little bottle. And Hugh was a really, how can I say it? He was extraordinary, a very modest person who delighted in his supportive help for. He provided multiple assistance at the time of internment. This is a little scribbled note which Hugh wrote to me on the subject of internment. He mentions Martha Vogt, and they were both A.V. and Hermann were really very, very helpful. And he says she escaped internment by a hair's breadth. Mentions also Max Perutz, who published a wonderful retrospective set of memories on his time as enemy alien, being Max Perutz, he could see something positive in the most despairing, darkest situation. So it's a terrific memoir which he wrote for the New Yorker. But it was so even for people who weren't interned, internment was a grave threat at the time. Why wasn't Hugh interned? Because he was a British subject in May 1939. I suspect that was at A.V.'s prompting, to promptly get British nationality as early as you could, sensing that there would be some sort of catastrophe was looming. Looking at the naturalization record for the National Archives, I noticed it's got a very, very long closure to January 2040. I think I will try and order this document and just see whether the closure is just very close for 100 years, whether it's a formal thing or whether there was some real reason there in this closure. I also think it's wonderful to hear that the Churchill archives on AV are fully open. So I think that's I think generous and far-sighted. There was, at the time of internment, there was a very, very close teamwork between Hermann and AV. I see this in this part of the papers which Hermann gave to me, or lent to me. Which is on the parliamentary debates. And all the parliamentary interventions by AV are on internment. That was I think there were six sets of questions and contributions to debates. So it was sort of like teamwork in Parliament. There was a Liverpool MP who spoke about women internees and so on, and then there was AV who was dealing with the scientific internees. So this was one of the cases that was raised, the neuroscientist Martha Vogt, and to prevent her internment. There's another set of correspondence with Miriam Rothschild, who was employing a naturalist from Berlin, a zoologist called Hartmann, who I think actually in the end had a breakdown under the stresses of the situation. But the idea was to establish a committee of the Royal Society to secure release from internment. That was, I think, the genius of AV, who was always, I think, looking for how to unpick and to sort of, you have a difficult administrative knot. Well, what you're going to find a constructive way out of this situation. And here one can see from the Royal Society the setting up with Henry Dale of the committee to advise the Home Office about internment, the members of the committee, of which AV you can see is the last on the list. We heard a little bit about Darwin. There's Bragg, I mean, it's a very distinguished committee. It's also it has the one distinction. It's the one committee that the Royal Society has lost its papers. It has, despite its very well organized archive, what it has is very, very fragmentary. But there are a few documents, and on the other side of the slide, you can see AV writing about the internment of aliens, the preparing, which was to extract internees was very labor intensive. You had to produce a set of documentation on the scientific significance of each person, what they could offer, science in general, or the British scientific war effort. So that a lot of work was involved, and also it became a whole system because in London, the Royal Society of Medicine undertook this role for medical internees who were numerous, against the British Medical Association. And it's the British Medical Association which AV has, you can say, in as a sort of, he feels is providing the great block and the great point of resistance that needs to be undermined, and so that he's fighting bitterly within the Ministry of Health and within Parliament, this opposition of the BMA. And in fact, I think he's one of the reasons for the Ministry of Health swinging round in late 1940, breaking away from the oppositional position of the BMA, and in January 1941 provides a really momentous recognition of most foreign degrees, although Blaschko points out that there's some degrees of neutral countries which are not recognized in the legislation, so they need to improve the legislation. But it provided a terrific, I wouldn't say a complete sea change. It was like a sort of health. If you were a refugee coming to Britain, the ups and downs were enormous, and this was a real. It turned the corner to an upswing of opportunity for persons with medical degrees who could then, for the rest of their lives, practice on a degree from Leipzig or Vienna, even though that degree might have been abolished by the Nazis. And they didn't know it, that the Nazis were systematically abolishing degrees like that. But we can see that the Central Medical War Committee was a highly, highly significant at the time of a lack of medical manpower, and as doctors were being called up into the forces, but also in accepting that doctors should serve the armed forces as well. So that was a fundamentally important change. So what Hill's aim is to try and break down the discrimination against refugee doctors as potential fifth columnists. He speaks about the unenlightened supposed self-interest of the Home Office's medical advisors. He says, I shall continue being nasty to the authorities and the medical people about this. So he still felt, even after this sea change with this degree, with this change of position, that a lot more work needed to be done to improve the position within the medical profession of a whole range of medical practitioners and researchers, who might well be the same person. We see this with the neurologist Ludwig Guttmann, for example, at Stoke Mandeville, in how Guttmann was really frustrated. He had a research position in the Nuffield Institute of Medical Research in Oxford, but his big opening was Stoke Mandeville, and where his achievements were terrific, but it also provided backing for the D-Day invasions. And one can see from this correspondence how there was a toing and froing of ideas between AV and Herman Blaschko. I've been bullying them both a bit. I've told the Minister of Health that now pro tem, okay, the quarrel is over, and I hope he will get over the difficulties of which you write. So that he's terrifically important, not only within Parliament, but also behind the scenes in lobbying AV. So immensely significant. I thought I'd end my talk with this little invitation to dinner given by former refugee university teachers and scientists, because AV's link to the not only to the organization, the Society for the Protection of Science and Learning, but also to the individuals whom he supported, Feldberg being a notable pharmacologist, was lifelong. And I think there's an enormous capacity for friendship and an enormous AV and Esther Simpson were so proud of each achievement of each of the refugee scientists. It's not just a refugee scientist like Bernard Katz in his laboratory, but it's also the wider community of the refugee scientists who contributed an enormous amount to the modernization and to the dynamism of British pharmacology, psychiatry, for example. Those are just two areas which really became world leading as a result of the contributions of medical refugees. So that I think it's a side of AV which cannot be praised in high enough terms. Thank you.
Well, Paul, thank you very much for sharing Blaschko's story with us, and in doing so, giving such a moving and personal tribute to Hill's humanity and humanitarianism. Certainly it's going to generate questions. Going to look for questions from the floor here, first of all. Adrian.
Thank you. I'd just like to say a little bit more about Bernard Katz, who you mentioned. I did know Bernard Katz, and particularly his two sons in an earlier life. He, of course, was a Jewish refugee from Leipzig and came to work with Hill at UCL and subsequently won a Nobel Prize in his own right. So his contribution was absolutely massive. I wanted to ask you, this UCL has cropped up today in several times, and UCL, of course, was an institution founded in the early 19th century on an entirely secular basis. It always had a very international view, strongly contributing massively to the education of nonconformists, of Jews, those who are not Church of England and obvious sort of Oxbridge type people. Could you say a little bit more about UCL and that?
Well, there's a personal side. My mother then went on to study at the University College Hospital. In fact, in her case, the dental school. I have a PhD from UCL. But I think there is an openness to taking refugee scientists there. If one looks at the patronage of refugees and the opening of doors to them, it's a very, very patchy situation. I think King's would be a little bit harder than UCL. In Oxford, there are certain colleges which do a terrific amount for academic refugees. All Souls, Magdalen, University College where Beveridge was, and Balliol, they're the stars who were magnificent in supporting refugees, whereas other colleges, the doors are effectively closed to them. So it's a very, very patchy situation. And then one sees, university, looking more generally, university senates and so on, for example, Queen's University Belfast, it closes its doors completely in 1940, won't even have people from the Republic of Ireland, and it separated out. But then in 1941, it starts giving scholarships to refugee students. So it swings round into, and one can see it was as if one sees two factions. I should know more about UCL and quite how it worked in detail. I mean, certainly Katz was one of these meteoric, it was a scientific meteor. I think did he have a Russian emigre background? I know Chain did. He was born and brought up in Leipzig. Okay. Then I'm muddling him up with Chain, who did have a Russian background, so emigre in a way twice over. Always a controversial person, but someone. Oh, you still hear people in Oxford saying Heatley should have got the Nobel Prize and not Chain and so on. There is still a sort of reserve about Chain, although his contributions as an organic chemist were fundamental for the penicillin work.
Okay, well, we have two questions, comments that have come in online, first of all. So from Austin Elliott, both of these, I have to say, are controversial in their own ways, I think.
Okay.
So, Austin Elliott, referring to the UK medical community's unenlightened supposed self-interest, is, for those who've read a lot of Hill's writings, strong stuff. He must have been very frustrated. Without wishing to introduce too political a note, I wonder if I'm alone in seeing disturbing echoes of some of our contemporary public discourse on refugees. Well, I'll leave it to you as to how much you want to go into the contemporary discourse. And then from Robert Boyd, do you know if AV ever commented on the interface between Nazi ideas and the UCL eugenics tradition?
Okay, I think for the last question, I don't think there was a comment there. Oddly, the what was called the Bureau of Human Heredity at UCL did have a refugee geneticist working for them. So you can give them a small staff for having a refugee on its staff. But yes, of course, it is a problematic situation, although British eugenics was never as bad as what the Nazis achieved. I mean, in relation to the modern situation, CARA has sustained itself. The idea that the SPSL should have its task was indefinite. And that was the idea in 1936. Well, here we are, is it 80 years on, still with a very problematic situation with well-qualified refugee scientists. Again, it's a great tribute to those colleges, universities who are prepared to support academic refugees. It is not an easy situation given the high costs. I don't know whether Churchill has got any refugees on its. It doesn't surprise me to hear that, but I think it's very much of a credit because making the arrangements are really financially. It requires a real contribution nowadays. I'm on the council of what today is CARA, so I have some insight. And it's very different to the German and French models, which are financed by their Foreign Office. And we have, it's very much of a voluntarily funded, I can say, the support for refugees, which for scientific refugees. So it's institutions, foundations like the Mellon, and individual donations. which sustain whatever is being done for academic refugees today.
One suspects this is an area that, if he were still alive, AV probably would be highly prominent and involved with. But looking out now for further questions from the floor. Nick.
I suppose this may also be a potentially controversial comment. I find AV's relationship to Jews a very interesting one in terms of his own background and the way he developed his friendships. He presumably had never met a Jewish person until he came to Cambridge. I would be astonished if he had. He must have known very little about the history of Judaism or Zionism. And yet, a few years later, he was becoming one of the central figures in protecting Jewish refugees and, in fact, protecting Jewish culture as well. He was. I was interested in Andrew's book that when Meyerhof said that he was saying how important it was that the Palestinian state should be, the Jewish state should be established in Palestine, that AV had replied saying, I'm not so sure about that. Displacing Palestinians from their rightful territory will be extremely disruptive and could possibly lead to to anger from the Muslim population. So AV was certainly not a supporter of Zionism at that point. But do you know anything about it? What did he inquire about, and what did he learn about Jewish culture? The Jews who we met continually in his home were delightful East Central European scientists and intellectuals. I don't think any of them identified with Jewish religion, but nonetheless, it must have been in the background. It was clearly in the background of Meyerhof too, although his family weren't Jewish. And either Andrew or yourself, I'll just tell one more story about this.
Mm-hmm.
A few years ago, I got a letter from an organization in Israel who said that I would be delighted on AV's behalf as his grandchild to know that he was about to be elected to be the group of blessed among the nations. And please would I convey to them what I thought AV would have thought about that. Well, I read probably much too flippant an answer, I think. I said, given he's turned down a knighthood, I think he would have been appalled to have been elected to be blessed among the nations. He didn't like that kind of pompous title, and I never heard any more back from this organization in Israel. But anyway, okay, I've said enough there, but can you or Andrew comment more on this complicated and interesting cultural relationship?
I only know one small fragment. As I said, my mother had an extremely warm and I can say AV was very interested and about, for example, conditions in Vienna and the persecution in Vienna, and asked extensively and took on board what my mother said about Jews having to scrub the streets and so on, which was a distinctive part of the persecution in Vienna. My mother felt so more insecure with Margaret Hill, and who did make certain comments about Jews, and my mother found it these were harder. But there was also a difference of opinion as to what my mother should do. Margaret Hill had a strong view that my mother should sign up for nursing, which was a perfectly reasonable suggestion, but was not something that my mother wanted to do. But certainly my mother detected a difference that, and I think found AV a much more enlightened spirit.
Okay, Andrew, do you want to come in on this?
I'm trying to remember the name. There's a historian of science at UCL, Charles
Singer,
who was Jewish and was in on the ground floor of the founding of the Academic Assistance Council, but wasn't allowed to be on the main committee because he was Jewish. And he did a lot in his personal capacity and through the AAC to house refugees and to put up refugees himself. I'm not sure where AV had his first exposure to Jewish people. He certainly knew Weissman in Manchester, who I think was instrumental in Bernard Katz coming to UCL. And in fact, Katz was really inspired by Hill's Huxley lecture in 1933, which represented him coming out into the political world with a very strong anti-fascist message.
I think one thing to add about Singer is there's a book called We Europeans, to which Julian Huxley contributed. And that was really, it dated, I think, from 1935 and was an attack on Nazi race science. And so one can see that it's not only rescuing persecuted scientists, it is refuting Nazi race theory, which in the case of Julian Huxley, he could do while being a eugenicist himself. He could draw a line on things like compulsory sterilization. So the odd, how can I say it, it is a complicated set of issues, certainly. And I do remember Robert Boyd telling me about, he had very strong opinions on Margaret Hill, actually, which was, I think, in contrast to AV. There's a slight dichotomy there. But in the case of my mother, there was an epic row between my mother and Margaret Hill. The row was over whether my mother should go into nursing or study. That was a clear difference of opinion on that issue. Although, to be fair to Margaret Hill, nursing was a perfectly good idea in that context for a young Jewish refugee who had no school leaving certificate whatsoever. So it was I think it's complicated regarding these personal problems and issues.
Okay, well, Paul, on that note, we should thank you again for coming all the way from Oxford to speak to us today. Thank you so much. And Andrew, it falls on you, I think, to introduce our final speaker of the day.
I'm delighted to introduce our final speaker, Alison Hill, who's probably well known to many of you here. We'd not met until today, although I did discover when I was going through AV's papers that there was a graduation certificate from Bristol in 1972. And AV had obviously gone to see his granddaughter graduate. And being a Hill, she was first on the stage because she got a first in anatomy. So I think you were the first on the list. And those of us who got 2 1s in psychology had to wait a little longer into the afternoon. But having studied anatomy, she qualified as a physician and has had a career in public health in, I think, Buckinghamshire and also for Public Health England. And like her grandfather, she could hop onto a bicycle and ride from here to Devon without any problem.
Thank you, Andrew.
Alison.
Yes, so I'm very honoured to be able to give reflections. I feel it's very self-indulgent that I'm able to talk about my time with my grandfather. Well, lots of us, lots of people here also share the same grandfather. Preparing for the talk made me think about what have I got, what records have I got, and I went to my folder, knowing that I'd saved some letters. And to my astonishment, I discovered there were 130 letters from my grandfather, written over 8.5 years, from October 1968, when I left for Bristol University, to April 1977, 2 months before he died. He started, so the letters are remarkable for the insights, just their humour, his love of family and of places, in particular Devon, his recall right to the very last letter of people, events, literature, the Bible, the state of the world and politics, if only at that stage to laugh at it. And quite often they acted as a reminder to me for some of the events in my life which I'd completely forgotten about. His epistolary style, I don't know how you pronounce that, was quite entertaining. Here's an example. It involved 2 different coloured ballpoint pens. The black was the narrative that he was reporting on to me, and then something would happen. And you can see here that in red ink, something happens. At this moment, does it say, I think Nick came in, and after some talk, we went downstairs for him to have 2 of Simon's photos. Simon, at that stage, I think this is Simon, Nick and Sarah's brother, who was doing some wonderful photography and colour photography. Then your mother arrived. Now it is time for the news. News over. Now your mother has been in for a chat. And then he moves on to something completely different, having finished. He never finished the top sentence because obviously it's he was obviously thinking about something else. And so the interruption was forgotten. And I think that's just a wonderful and charming way he wrote. Given that places featured so much in his letters, I framed this talk around the places that meant so much to him and are reflected in the letters. To start with his return to Cambridge in the last decade of his life, our parents and us 5 children lived in a large house in Chaucer Road. After our father Morris died in 1966, Philippa converted the end of her house into a flat. Marge was very ill at that stage with Parkinson's disease, and her mobility was very severely limited, and she was extremely frail. So when Philippa invited Marge and AV to come and stay in the flat, I think they took up the offer really gladly, and I imagine with a lot of relief. So they moved in 1967. AV had a large study and bedroom upstairs looking out over the back garden, and the rest of the house was rather dark and on the ground floor at the opposite end of the house. As soon as they arrived, the redoubtable Susan Rendell came to look after the 2 of them, acting as housekeeper and carer for Marge. Susan had a long connection with the family as she was a carer to Marge's parents, John Neville and Florence Ada Keynes. Marge died in 1970, and Susan continued to look after AV and was very much an integral part of our grandparents' old age. She was particularly good at making immensely sweet puddings. These are the words my sister Julia wrote. However, as in almost everything, AV had very simple tastes in food, and there was nothing he liked more than rice pudding. He particularly loved the burnt skin at the top of a rice pudding, which I think a lot of people's stomach might heave over. So one summer I stayed with him and Susan while the rest of the family were away. Every lunch, Susan produced 2 puddings. So she would always ask him, which pudding would you like, this pudding or the rice pudding? And invariably he said the rice pudding. So unfortunately, I then had to eat the other pudding. And it was the only time in my life that I put on weight. In his letters, he writes much about the people who dropped in to see him. He relished visits from his grandchildren. He also mentions the help he got from various people who worked with him, kind of sorting out his papers. Hilda from Belgium, Kazumi and Sumi from Japan, Dalvia, who I can't remember, but he talks about a lot and is described in this letter as a granddaughter honoris causa, and Kate Naif, who was a daughter of a friend of an American colleague of our father's. They all kept in touch with him after they left, and in his letters he reported on what they were doing. And this is a picture of Kate. NAIF with AV in 1974 when she came and spent some time with him. A favourite visitor of his was Iris Gaddam, who was a physician and lived locally. She popped in regularly to see him, and her husband Jack was a pharmacologist in University College between 1935 and 1942, so no doubt AV had known them for many years and reconnected with Iris when he and Marge came back to Cambridge. He writes in 1975 to me that he and Iris were of the view that I should do the MRCP and become a physician, and it wasn't a difficult choice to take up that advice. The place he loved most of all was Devon, and I think several people have commented on his love of Devon. This deep attachment started during his school days in Blundell's School near Tiverton. He and Marge had a family house near Ivybridge, looking over Dartmoor, called Three Corners, and his shorthand in the letters is a triangle for Three Corners. The connection strengthened through his links with the Marine Biological Association laboratory on the Hoe at Plymouth, which was a place he frequently visited for his research. In 1971, I joined AV and David on a 3-day trip to Blundell's to celebrate the most famous Blundell's old boy. He donated a bust and several medals, which I've looked up. The Medal of Freedom with Silver Palm, given to him from the USA in 1947, the Companion of Honor, 1948, the Légion d'Honneur in 1950, and the Key to Tokyo. And now Blundell's also has the Nobel Medal. AV struck up a great friendship with Colin Beale, who was the bursar at Blundell's, and helped pull out all the stops to make this visit so special. AV dreamed of a return trip to Blundell's, and in a letter in 1974 wrote about Maggie. Maggie's David's daughter, who was in training to be a pilot at the time. Maggie and I are having a great lark discussing with Colin Beale how she could fly me to Blundell's on or near my 89th birthday and land in the school field. Sadly, he never made it, and when I spoke to Maggie about this, Maggie felt she wasn't really a safe pilot to get him there. In February 1974, he wrote about an extraordinary walk he took on the 9th and 10th of April 1906, his first Easter vacation from Cambridge. He started at 9:15, well, you can see here, it started at 9:15 from Tiverton, 9:15 p.m. from Tiverton, walked to Dulverton, then by moonlight to Haddon Hill and back via Moorbach and Brampton, ending up on his favourite Exeter or Crisscross Hill to see the sunrise. I estimate it was well over 30 miles. In other mentions of Crisscross Hill, he says he could see most of Devon. And prompted by a comment about bluebells in a letter from me in May 1973, he wrote, "The best bluebells I have ever seen were at Start Point in May. They merged with the blue sky at the top." So he's got a little diagram up there with AVH at the bottom. Oh, sorry, that's laser. AVH at the bottom, the bluebells up the slope and up to the sky. I thought it was really charming. And Dartmoor features very much in his letters. A family camping holiday in 1927 up on the moor had to be curtailed when all the family except AV and Morris went down with the mumps, and they all had to retreat to a farmhouse owned by a kindly and appropriately named Mr. Mumford, but AV calls him Mr. Mumford. I can picture him poring over his wonderful collection of Ordnance Survey maps in his room upstairs to find the exact location of the campsite, which I found on, so there's the campsite, there's Mr. Mumford's farm, Wisdom Mill, and he also talks in here about Hilson's house, 1360 feet there. So easy for me to do this because I have a digital Ordnance Survey map. I think it might have been more difficult to find the grid reference just on a paper map. Plymouth had a very special place in his heart. When we grandchildren reached a certain age, the older ones amongst us were taken one or two at a time by AV for a visit to the city to show his grandchildren the things he loved most about the place. Julia and I remember being driven down there by him, and we stayed with him in the Strathmore Hotel on the Hoe and visited Eric Denton, director of the Marine Biological Association, and his wife, who were great friends of his and get many mentions in the letters. And we also went out with great excitement on one of the research ships, Sarsia. Because Plymouth meant so much to him, I took up his wish that at least one of his grandchildren should spend some time in Plymouth. And I went to Devonport Hospital to do a house job, a locum house job in January 1975. Plymouth captivated me too, and after qualifying, I went back to do my surgical house jobs in the same hospital. He revelled in the descriptions I sent him of the naval dockyard and the views over the Hamoaze with the mothballed Ark Royal and Eagle aircraft carriers, and of regular trips to Dartmoor. And he would have been so pleased to know that my brother James also ended up working in Plymouth, later on staying on as a GP in South Brent near AV's beloved Three Corners and Dartmoor. And I'm glad to say also one of his great-granddaughters, Emma, and two great-great-granddaughters live in Plymouth now as well. Bristol is another place that was important to him. Even if it wasn't a city he loved, I got no sense that he loved Bristol. I think it was, but it was an important place, being the gateway to the southwest. He was born in Clare Road, Cottam, as Andrew said, and lived in Bristol until the tragic collapse of his parents' marriage. But lots of his descendants have studied in Bristol or lived in Bristol. Strangely, our father, Morris, was sent to school briefly in Clifton, Avondale School, because he wasn't making much progress in Highgate. Grandchildren James, Charlotte, and I went to the university there, and Griselda, much to AV's delight, went to Exeter University, Griselda being our sister, and she later on moved to Bristol, and now 3 of his great-granddaughters live in the city. Jenny Hill, who wrote a dissertation about AV and his work on the Academic Refugee Council when she was doing her undergraduate degree in history, Sarah Chivers, my daughter, and Thea Hill, Griselda's daughter, and a great-great-granddaughter just born. There was one visit A.V. Hill made to Bristol, and Andrew has commented on this, which is the trip to my degree ceremony. So here it is. Here's the pamphlet with my name there and Andrew's name there. I was very touched and incredibly honoured that A.V. came along. But I think it's a wonderful coincidence. We were all in the same space at the same time. And I think that's probably the closest you ever were to A.V. His last 10 years were filled with niggling ill health, but nothing that stopped his joy in family, the constant drive to order his books, his kind of reflections on friends, and also his prolific writing. Walking was difficult for him. His legs didn't work very well. He said it was circulation. His teeth were a problem, and I found this rather nice quote. "I have only 5 stumps left. Susan, quarter of a century younger, has no teeth at all." He had arthritis, particularly in his right wrist, which he claimed affected his writing, though it wasn't evident from the volume of letters that he continued to write. Treatment of arthritis with a non-steroidal and anti-inflammatory drug caused a gastric ulcer, which he grumbled about, and our brother James kind of took him to have an X-ray on it. In 1971, though, was a very significant event when he started falling about a lot and becoming very confused and forgetful. His son David wrote to me after our Blundell's visit saying, "I'm afraid the prospect for AV is not good." But it was then discovered his doctor was prescribing barbiturates. The drug stopped, he returned to himself, the doctor was sacked, and he lived another 6 years. So he continued to enjoy life right to the few final weeks. Here are pictures of him in 1977, March 1977. The one on the right is his great-grandson, James Riley. And so this was 3 months before he died, and looking very, very healthy and hearty. He did, though, recite a poem to me on a couple of occasions. I don't know why I remember it, but it was called The Deacon's Masterpiece, or The Wonderful One-Hoss Shay, A Logical Story by Oliver Wendell Holmes. And I'm just going to recite this to you. Have you heard of the wonderful one-hoss shay that was built in such a logical way? It ran 100 years to a day, and then of a sudden it... Ah, but stay, I'll tell you what happened without delay. I'm not going to go through the 100 years. So the poem goes through the 100 years of the one-hoss shay to its final demise. It went all to pieces, all at once, and nothing first, just as bubbles do when burst. End of the wonderful one-horse shay. Logic is logic, that's all I say. And he really obviously wanted to go in that way, and he did in the most masterful way. He just went downhill in 2 months and died. So, I think he managed his end really well. And this is the very last letter I had from him in 1st of April 1977, just 2 months before he died, and is so typical of all the preceding ones. It introduces me to an Irish woman called Colleen, who he wants her to visit Plymouth. It advises her she should go to Start Point below the lighthouse to see the bluebells merging with the blue sky at the top of the cliff. He reports on David dropping by and ends with a mention of Iris Gaddam, whom he thinks I ought to meet. She will be glad you are following her example and her advice. Love to you from Grandpa. Thank you.
Alison, thank you so much for sharing something of the man behind the science and the politics. And it's great to see that system of multitasking in letters. Okay, so a final chance for questions, and then I'm going to let Andrew have a few words, if you would like, at the end. So questions for Alison. I know that we've got other family members here. Do feel free to add your comments if you wish to. Okay. Any comments or questions? Okay, we've got a question up here.
Can I just ask, did you ever discuss with him why he turned down the knighthood?
I think he... the letters reflect quite a lot on that, because he objected to these honours. He did accept I don't know if lots of us will remember how he used to quote Kipling to us, a poem, He, Thank God, has an OBE. And in fact, do you remember that, Nick? And I remember the very first time I ever went on Twitter was because over this very question that Austin Elliott, who's listening or watching, wanted to ask that very question. Why did he not want like honours? And I think he just felt they were pretentious, and so I was quoting that Kipling to Austin Elliott at the time. That must have been about 10 years ago. But I think Nick may know more, other family members may know more about that.
Does anyone want to come in on that?
I think the Royal Society were very keen for him to accept a knighthood because he'd been the biological secretary and the foreign secretary for so long. And he was adamant that he wasn't going to do it. And there is actually a note about it in his papers, and he cites all the great predecessors who were fellows of the Royal Society who didn't have knighthoods, like Darwin, and then he talks about Brunel. And he thought it would be a bad thing if every officer of the Royal Society expected a knighthood as a matter of course, and thought that it was a way to keep some independence from the government.
I think he did have an OBE.
Yes, he did.
And
from the First World War, from the
yeah.
brigands.
Yes.
A lot of them got them.
And he did have a companion of honour, which in a way is very classy.
That Sir Henry Dale insisted really that he wrote to Attlee to say that AV was stepping down from being an officer of the Royal Society and that he'd had no public reward for everything he'd done. And AV accepted the Companion of Honour because it doesn't come with a title.
Okay, Susanna?
My mother always said that Marge was very cross because she would have very much liked to have been lady. So, I mean, there was always that element. And my mother also felt that he slightly shot himself in the foot because he offended people by turning it down and then did not become President of the Royal Society, did not become Master Trinity. And my mother always linked these things together. And she said, I don't know if it's true, that he was offered Master of Balliol and turned that down, but then didn't get Trinity. But my mother always felt it was a bit of a... But she also felt that the other stories I know about AV were that he only ever read Lorna Doone, and that was the only novel that was worth reading, so you don't read any more, a bit like Nancy Mitford's Uncle Matthew. And she was furious because she, and I assume Janet, was sent to a Unitarian school, so they were never taught anything about the Bible. And she was then always told off by him because she didn't know the stories. And he particularly liked an Old Testament story about, do you remember this? Who was always being quoted. Sorry? Well, a prophet being chased by a bear and being and a prophet having problems with children.
Elijah and Elisha.
Yes, well, there you go, you see. And so he would say all these things, and then my mother wouldn't know any of it, and she felt very sort of put out by it. But my only memory that I really want to share about AV, it's a very short one, was that as a very small child, I used to go and stay from Cambridge up there for the weekend, and I had a little box room next to his study, and he had a bookcase with glass on it, and he'd put a little cardboard cutout pipe so that when you had a light, it looked like a man in a stove hat, the shape of the bookcase, and then his nose, and then the hat, then the little cardboard pipe sticking out the bottom.
Okay, well, I think we must bring things to a conclusion now. We do have online a further comment from Robert Boyd, which goes back to the last session, to Paul's session. And Robert just says, in response to Paul, my mother was 3/4 Jewish, yet Margaret was very close to her. So he wanted to make that point. But Andrew, I mean, you're really the person responsible for bringing us all together today. We've got this fantastic book, which I encourage everyone to go out and buy and read. Are there any sort of further points that you want to make at this point?
No, I would just like to thank you all for coming and for the people online for tuning in. I'm particularly grateful to the speakers who came here today, and I just think that the Hill Archive is a stupendous collection, and that he was such an important figure in the 20th century history of Britain.
Yeah, and I think there's an awful lot of potential within the archive that is yet untapped.
Agreed.
So we should speak about ways in which we can encourage more people to follow up on your research.
I would just say on Alison talking about the camping holiday in 1927, there's a photograph on the back of my book, which I sent to OUP telling them it was the camping holiday in 1927. And there's a picture of Otto Meyerhof and A.V. Hill, both in three-piece suits wearing a tie. Yeah, that was camping in Devon.
Well, he went on that?
Yes.
Oh,
he was there when they found the field for Three Corners.
Oh.
Okay, well, I think we are now into the thank yous. I want to thank Amanda for actually doing all of the organisation that has made today possible. Thank you so much. And also our wonderful AV team. It seems very appropriate to call them an AV team this afternoon for actually making sure it all works so smoothly. So thank you to Chris and the team upstairs. As Andrew said, thank you to all the speakers, to Nancy, David, Paul and Alison. Thank you to all the Hill family for coming and supporting this. And I think now is the time to adjourn for drinks. But before we do so, I think that the person that we really need to thank for today is Andrew for bringing us all together. Thank you so much. And we can now head around the corner to the Jock Colville Hall within the Archive Centre, where hopefully drinks will be awaiting us. And I will nip upstairs and open up a display of some of AV's papers for you to enjoy.